Do you know what can fail in an ignition coil? How to diagnose its common failures, when to replace it and how to do it? No worries, Nissens experts are here to help. The ignition coil is a key engine component of an internal combustion engine. Its main function is to convert low voltage from the vehicle's battery, 12 volt, into high voltage energy up to 60 kV, which are needed to generate spark to ignite air-fuel mixture in the combustion chamber. A properly functioning ignition coil is highly important for proper reliable operation of the engine, thus its performance. In this video, we'll review the most common ignition coil failures, we'll inform how to diagnose them, when to replace an ignition coil, and finally, how to do it. A faulty or non-performing ignition coil manifests through a range of easy-to-recognize symptoms. Let's review the most common ones. The check engine light is often one of the first indicators with the ignition coil trouble. You'll be looking for trouble codes for a cylinder misfire or fault within ignition coil circuit, respectively P03OX or P035X. Hard start or no start. A weak or failed coil can cause extended cranking or prevent the engine from starting, especially in cold conditions. Engine misfires and rough idle. Misfiring cylinders result in rough idling, shuddering and poor acceleration. Engine stalling. Intermittent coil failure may cause the engine to stall unexpectedly, posing safety risks. Backfiring or problems with catalytic converter. As onboard fuel gets inside of the exhaust system, in older cars it could produce loud pops and explosions within the exhaust system. In modern cars, it can really damage the important part of the system, which is the catalytic converter. Weak spark generates poor output of the engine and increased fuel consumption. An effective diagnostics of ignition coil failures involves combination of visual inspection, electronic testing and practical techniques. OBD scan. Retrieve misfire and coil circuit codes to identify affected cylinders. Visual inspection. Check for cracks, carbon tracking, oil contamination and connector corrosion. Spark test. You can use a simple inline spark tester to verify spark strength and consistency, or you can use a more advanced tester type to check the voltage generation by the coil. Coil swap test. Move suspect coil to another cylinder and observe if the misfire problem follows. Resistance measurement. Use a multimeter to check coil windings against manufacturer specifications. So what can break in the ignition coil? Ignition coils are subject to various stress factors. This can lead to the failure. Understanding this mechanism helps in accurate diagnosis. Open or shortened windings disrupt the coil's ability to generate spark. Overheating and age are common contributors, and OE coils often fail early due to poor thermal management. Same with the low-quality coils, which use inferior copper windings and insulation, increasing the short-circuit risks. Insulation breakdown and arcing. Cracks in the coil's resin casing or carbon tracking allow voltage to escape, causing misfires and visible sparks. Heat-induced epoxy cracking is a known OE flaw, and aftermarket coils with low-grade epoxy often suffer even faster degradation. Connector and wiring issues. Loose or corroded connection or damaged connectors can mimic coil failure by interrupting power or signal flow. Multiple coil failures often link to underlying issues such as excessive spark plug gaps, lean fuel mixture or faulty ECU drivers. These conditions overstrain coil and leads to repeated failures. Improper coil impedance is a condition which disrupts voltage buildup, causing weak spark and misfires, often due to winding damage. OE and low-quality aftermarket coils frequently fail to maintain proper impedance condition, leading to erratic ignition and ECU stress. So, when to replace the coil? The ignition coil is a sealed high-voltage component and cannot be repaired once damaged. Its internal windings, insulation and electronics are not serviceable. Here is what we recommend. So, replaced by confirmed coil failure, internal breakdown, voltage leakage or severe performance degradation detected during diagnostics. Replaced by persistent misfires, spark delivery issues causing rough running or poor combustion. Remember to replace all coils in high-mileage engines, as one coil failure often signals others nearing end of life, hence replace all for balanced performance. Avoid reusing or patching. Attempting to repair a failed coil can lead to recurring issues and damages to other ignition system components. Finally, keep in mind, driving with a failed ignition coil risks harm to other internal engine parts and emission components, such as catalytic converter or oxygen sensor. How to replace the coil? The following guide covers the most common replacement steps for typical 4-cylinder engines with coil-on plug or Prenson coil design. For vehicle-specific installation instructions, always consult the official vehicle and OE documentation. Switch off engine, remove key, allow it to cool, remove engine cover and any components blocking access. Disconnect PCV hoses or harness retainers if required. Clean area, blowing out dirt and debris from the coil and spark plug wells. Disconnect electrical connector, remove mounting bolts, twist slightly and pull out the coil. Check the coil boot and seal for damage. Replace damaged boots or seals if necessary. Install new ignition coil. Insert coil fully and correctly aligned. Install and tighten bolts to specification and reconnect electrical connector. Reassemble and final check. Reinstall the removed components and engine cover. Run the final OBD scan and erase any stored OBD codes. Start the engine and verify proper operation. After the final check, the last OBD inspection, erasing the stored error codes in the memory, and the inspection whether the engine works all the way it should with the all set of ignition coils, now is the time to take the car on the test drive. If you want to learn more about Nissens ignition coil, visit nissens.com/ignition coil, and for more technical insights, visit nissens.com/experts.